Hello everyone, and welcome to Del Monte and Science. I'm Lou Del Monte. Today I'd like to address an age-old question. Is time travel possible? And so let's just discuss that. This has been discussed a number of times, but I'm going to actually present some new data that hasn't been presented in any other media. So, the nature of time has been debated for well over 2,500 years, and the whole aspect of time travel was popularized about 100 years ago, in 1895, by H.G. Wells. So in 1895, H.G. Wells publishes his famous novel, The Time Machine, and he sets the imagination of the world on fire about time travel. But let's ask a serious question from the standpoint of science, from the standpoint of physics. Is time travel possible? Well, there's no law of physics that prohibits time travel. Said more positively, there have been numerous solutions to Einstein's general theory of relativity that indicate time travel is theoretically possible. And we have done in the laboratory, and this lends some credence to the whole idea of traveling in time. In the laboratory, we've done time dilation experiments in accelerators, particle accelerators. And as a point of fact, a particle that may have a very short lifetime, when it's accelerated near the speed of light, can have a lifetime 10 times longer, or even longer than that. And this is called time dilation. So the particle actually, in a sense, travels to the future. In a sense, that's what's happening. Now, science has proposed three methods to do time travel. None of them are within the grasp of today's science, but I think it would be very interesting to survey them. What are the three methods that science proposes that we could use? Well, the first method would be faster than light time travel to the future. And what this says is, this is part of Einstein's special theory of relativity, that if I take a clock, just an ordinary clock with hands on it, etc., and I accelerate this to near the speed of light, and I'm using c as the speed of light in a vacuum, as I accelerate this clock near the speed of light, the hands move slower. The clock actually moves slower. So that if you were able to get in a rocket ship and travel into space at near the speed of light and then come back to the Earth, you would have aged very little in comparison to those people that were essentially stationary on the Earth. Now, I know the Earth isn't stationary, but the Earth isn't traveling near the speed of light, neither are those people. So that's the first method that has been proposed, faster than light time travel to the future. And let's be clear about one thing. No mass can actually exceed the speed of light. That's a law of the universe. It's predicted by Einstein's special theory of relativity. But that's one of the methods. Approaching the speed of light is probably a better way of saying it. That's proposed for time travel. The second is using wormholes. Okay. Now, what is a wormhole? Well, it's a theoretical entity in which space-time curvature connects two distant locations or times. So, in effect, and this, you often hear this type of terminology used in conjunction with how can we go from one planet to a very distant planet, say 600 million light years away. How can we make that distance, that jump? And people are saying, well, use a wormhole. And basically, the wormhole does this between two planets. And it would be similar to me taking this piece of paper, here are your two distant planets, and folding the paper. That's what the wormhole does. And so you essentially travel a shorter distance. And it appears that you've traveled faster than the speed of light, but actually you've used the wormhole to do it. As I said, today's science does not know how to create wormholes. However, we can infer, wormholes exist from Einstein's general theory of relativity. And the third method is to use black holes. Now, why black holes? What is a black hole? Black hole is a collapsed star, and essentially it's called a black hole because the gravity is so dense that not even light can escape. And the reason why people are saying, well, maybe black holes hold the key to time travel is that, in effect, there's a lot of energy in the black hole, and people are saying, scientists are saying, that, well, you need a lot of energy if we're going to time travel, so ergo, why don't we consider a black hole? But none of the three methods, none of these is practical in today's science. In addition, a number of scientists have brought up another obstacle, and that is time travel paradoxes. And basically what they are is thought experiments that illustrate that time travel might potentially violate causality, cause and effect. And the most famous one is, I'm going to take this off now, the most famous one is the grandfather paradox. And basically this paradox says that you go back in time and you meet your grandfather. And you change events such that your grandfather never has the opportunity to meet your grandmother. Therefore, what occurs is that they never marry, and theoretically, you're never born. So what happens to you? It's a paradox. Do paradoxes actually mean we can't time travel? And some physicists have thought, yeah, maybe they do, but the majority of physicists are arguing, no, they don't. As a matter of fact, Kip Thorne, who was an American theoretical physicist, and he was a professor of theoretical physics at California Institute of Technology until 2009, said that he argued, that time paradoxes are imprecise thought experiments which can be resolved by numerous consistent solutions. So most of the scientific community says time paradoxes do not prevent time travel. So we started with a very, very simple, deceptively simple question: is time travel possible? And the answer is the scientific community believes it is. In the next post, we're going to talk about some new science that I have published in my new book, Unraveling the Universe's Mysteries, available at Amazon.com and also at Barnes & Noble online. And we'll talk about how that theory enables us, gives us another tool to understand time travel. Thank you.